Well, over the years, a number of my colleagues have made comments similar to this one, and being a big fan of Monty Python, I can't help but run with that analogy probably a lot further than they ever intended. Of course, they meant that being able to tell the age of your animals is of central importance to the science behind sustainable fisheries management. And until now, we've had no way to tell the age of some of our most valuable fisheries animals, the crabs and lobsters. And like Arthur's grail, no one's known where to look for that method, no one's known what it would look like if they did find it, and most believe that such a thing couldn't possibly exist in the first place. Why not? What's the problem? Well, by direct aging, I mean being able to assign a precise age to each individual, usually by extracting a hard structure such as a bone, a tooth or a shell, whose internal appearance varies according to the rate and temperature of deposition, so that when viewed in cross-section, that structure will have alternating layers of summer and winter growth. And by counting the layers, you get the age of the animal. That's how you tell the age of fish, corals, clams. Why not crabs and lobsters? They've certainly got plenty of hard parts. But like a knight in shining armour, they wear them on the outside, an exoskeleton. And when they outgrow that skeleton, they have to molt, shedding all their old hard parts and growing a completely new set, thereby erasing any record of past variations in growth. So for us, the grail was a hard structure in crabs and lobsters that's not lost in the molt and which retains those seasonal layers. And that's what we've found. But why is that so important? Well, picture the habitat supporting a lobster population as a great big pot, half full of lobsters. Now, when it's only half full, there's plenty of spare resources in that pot, and life for the lobsters is relatively easy. So they grow and reproduce at maximum rates, and natural mortality is at a minimum, and the population expands until it fills the pot. Now, if we fish that population, we add another term to the mortality side, and if we pick the right amount of fishing mortality, we can balance the two sides so that the pot will never fill, but nor will it ever empty. And that's the essence of sustainable fisheries management. Now, you can see that in order to estimate just how much fishing mortality that pot can sustain, you need a pretty good idea of the rates of these other three processes. And the trick is that all three of those processes depend very much on the age of the animals in your pot. Younger animals grow faster, reproduce less, and tend to die at higher rates than older ones. So that's why accurate age determination can be the grail that grants eternal life to a sustainable fishery. So to our quest. And those of you familiar with the Arthurian legend will be saying, hang on, he's pictured himself as Arthur, and Arthur never found the grail. That was one of his knights, Sir Galahad in fact. No, Arthur's role, like mine, was to assemble a team, educate them in the value of the grail, train them in the skills they would need to find it, equip them, send them on their quests, and when they return, help them make sense of what they'd seen. Galahad in this story was my then honours student Jesse Leland. Now, Jesse's quest was to find the age of giant beachworms, but that's for another 5 minutes. In the process, he read about a structure in the stomach of crabs and lobsters called the gastric mill. It's a series of grinding plates supported by bony ossicles. And when we looked at the molted exoskeleton of a lobster, there were the grinding plates, but where were the ossicles? So he ran down to the co-op, bought some crabs and lobsters, whipped out the gastric mills, and set to work with Excalibur. And yes, the resulting cross-sections of the ossicles did have layers. What's more, the number of layers corresponded with the approximate expected ages of those animals. So we got excited and ran off a little paper that basically said, look, if these layers should in future prove to be an annual cycle, as we think they are, then just remember everybody, we saw them first. Now, that proved to be a good move because less than a year later, a team from Canada, we like to call them Mordred, showed that the layers in the ossicles of American lobster did follow an annual cycle. So, game on. We got a grant to look at subtropical estuarine mud crabs and freshwater crayfish, and just this year showed that in those two habitats, the layers were again an annual cycle. So we now have a large Fisheries Research and Development Corporation grant to coordinate a national network of researchers to apply these methods to some of Australia's most commercially valuable and culturally iconic crustacean fisheries, including, amongst all these other species, our most valuable single species fishery of all in Australia, the western rock lobster, the world's largest rock lobster, the eastern rock lobster, and my favourite animal, the world's heaviest commercial crab, the Tasmanian giant. Together with some international projects, this means that our method is now being used to make the world's crustacean fisheries more sustainable. And just to close, the grail analogy does break down at this point, fortunately. Arthur's still alive for a start. Mordred turns out to be a nice guy that we can collaborate with. And my wife assures me, with perhaps a hint of disappointment in her voice, there is no Lancelot amongst my postgrads. Thank you.